Go to a balance and measure out 56 trillion iron atoms. Then combine them with 108 billion oxygen molecules. Hopefully, you could see the flaws in these statements. How are you supposed to measure out 56 trillion iron atoms? There has to be a way to count and measure atoms, but because they are so small, and we will usually be dealing with so many of them, that a different method needs to be used to count out and measure these little guys. If a dozen oranges weighs about 5 pounds, and I wanted you to get me 50 dozen oranges, what could you do? Well, you could either count out 600 oranges, which would take a while, or you could keep adding oranges to a scale until you reached 250 pounds. That's 50 dozen times 5 pounds per dozen equals 250 pounds. I would opt for the second choice, because then I wouldn't have to worry about whether I lost count, and I wouldn't have to keep track of oranges. I would just have to focus on getting 250 pounds of oranges. This exact same idea is used in chemistry, because it would be ridiculous to count out individual atoms. Again, just like the oranges, we will rely on their weight as a tool to help us count them. So, will we be grouping them in dozens and weighing them in pounds? Probably not. We will be using what we already know about the weight or the mass of an atom. We can find the atomic weight right under its symbol on the periodic table. What do you notice as the atomic number, the top number in each box, increases? You should see that as you move from left to right and top to bottom on the periodic table, the atomic number, which is the number of protons, increases by 1, and the atomic weight also increases. Atoms of each element get heavier because they are holding more protons and neutrons. Well, and electrons too, but this really doesn't have an impact on the mass. So atoms of each element have a different mass. For example, the average iron atom will have a mass of 55.8 AMU. Remember that 1 AMU is very small, about the mass of a proton or a neutron. And because balances in the chemistry lab don't measure in AMU, we are going to need to scale this up to something they do measure, grams. Just how many AMU are equal to 1 gram? The answer to this is a very, very large number. 6.02 times 10 to the 23rd. That is 602 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. I don't even know what that number is called. And that's okay, because this number has its own special name. Kind of like 12 has its own special name, dozen. Its special name is Avogadro's number, which is named after this guy. Avogadro's number is more commonly called the mole. The mole is just a large number, a way to count how many of something you have, and obviously a very large number. It is always equal to 6.02 times 10 to the 23rd. It is the number of AMUs in 1 gram. So 1 mole of AMUs equals 1 gram. This is a relatively simple concept, but it tends to be one of the biggest hurdles to learning chemistry because it is a number so large your brain has trouble even comprehending it. Here is an example. If I had a mole of basketballs, 6.02 times 10 to the 23rd basketballs, it would be nearly the same volume as the Earth. Ready for another? If I had a mole of dollars and I spent $1 billion every second, it would take over 19 million years to spend it all. Okay, back to chemistry. If 1 mole of AMUs is the same mass as 1 gram, and 1 hydrogen atom has a mass of 1 AMU, then 1 mole of hydrogen atoms would have a mass of 1 gram. What about our iron from the beginning of this lesson? If 1 iron atom has a mass of 55.8 AMUs, then a mole of iron atoms, 6.02 times 10 to the 23rd of them, will have a mass of 55.8 grams. Let's take this concept and do a little more practice with it. Get your periodic table handy and feel free to pause the video to figure out the answers on your own before I explain the answer. First, find gold on the periodic table. It has the symbol AU and is located slightly to the right of the center of the table. Say I have a pile of gold, and it has a mass of 197 grams. How many moles of gold atoms do I have? The answer is 1 mole of gold atoms. If I could count each individual atom, how many would I have? The answer is 6.02 times 10 to the 23rd atoms of gold. Notice how I started out with what I was given, and then I multiplied by a conversion factor, which is really just an equality that I turn into a fraction in order to be able to cancel out the units I don't want and turn it into the units I do want. Here's another. Find calcium on the periodic table. It has the symbol Ca and is located on the left side. A brick of cheddar cheese contains 3.01 times 10 to the 23rd atoms of calcium. How many moles of calcium atom does it contain? The answer is 1/2 of a mole, because 1 mole is equal to 6.02 times 10 to the 23rd atoms, so 1/2 of a mole would be equal to 3.01 times 10 to the 23rd atoms. Okay, so if it contains 0.5 moles of calcium atoms, how much mass would that have? The answer is about 20 grams. The mass of 1 calcium atom is 40 AMU, so the mass of a mole of calcium atoms would be 40 grams. We don't have enough for a full mole though, only 1/2 of a mole, so the mass would be 20 grams. One last problem. Find helium on the periodic table in the top right corner. If I fill up a balloon with 2 moles of helium atoms, how many helium atoms would be in the balloon? If 1 mole of atoms is 6.02 times 10 to the 23rd atoms, then 2 moles of atoms would be equal to 1.2 times 10 to the 24th atoms. You may not normally think of a helium balloon as having any mass, but it does. It is just so much less dense than air that it floats in air. So if I have 2 moles of helium atoms, what would the mass of all of these helium atoms be? The answer is about 8 grams. If 1 atom of helium has a mass of about 4 AMU, then 1 mole of helium atoms will have a mass of 4 grams. Well, we were asked about 2 moles, so we would need to double this value, getting 8 grams. Here are some helpful hints to use when solving these types of problems. First, estimate. Are you going to have a very large number? Maybe a very small one. Also, always remind yourself that a mole is just an ordinary number. Just like a dozen is 12, a mole is 6.02 times 10 to the 23rd. Yes, it is a big number, but it will always be that same number, whether you're talking about basketballs, dollar bills, or atoms. Next, don't be afraid of the periodic table. It is super helpful, especially the atomic mass, because not only does it give you the mass in AMU of 1 atom of that element, but it also gives you the mass in grams of an entire mole of atoms of that element. Finally, celebrate Mole Day. It starts at 6:02 in the morning every year on October 23rd, or 10/23.